Hi, friends. Welcome again to another episode of Beyond the Clouds Edge to Edge Transformation. This transformation is literally global. It's not only affecting the rest of the world, it's also being influenced by people around the world. And among the people I got to know in this journey is Alex Myakov. Alex literally has traveled to more than 40 countries around the world and has worked in different geographies. And part of his mission is to help people understand what AI is and what AI is not. Alex, tell us about your journey. How did you become the Alex that we all know today?
I was born into the family of couple PhDs in chemistry, and in the Soviet times, USSR, long time ago. I chose physics as my thing. I did bachelor's and master's in physics, couple grad schools, and in physics and electrical and computer engineering, one in Russia, one in the States. Then I turned to the dark side of business. So I left academia, did 3 biomedical startups and focused on productization of early cancer diagnostics tools. One of those was optical coherence tomography, which is widely used right now in ophthalmology, for instance. I switched from academia and physics and early cancer diagnostics and moved away to software. And I spent a few years working as a VP of business development, a company called Mera, working with very large telecom companies like Ericsson and Nortel and Avaya, Alcatel-Lucent, just to name a few. And that's where I kind of grew my tasks of creating business, selling services and selling software, big companies globally. I moved away from a big company to a very small startup called Itseez. I was actually invited by one of the co-founders, another physics guy, the guy we went to school with, Viktor Yerohimov. He wanted to leverage my business development and sales experience, and he invited me to join them. I eventually became one of the co-founders of the company and the CEO. What was special about Itseez was that Itseez was working on computer vision. Itseez was the maintainer of a very widely popular computer vision library called OpenCV. When I joined Itseez, we were a company of about 30 people, more than tripled our size, doubled our revenue within a couple of years. What's important for me personally is that the renaissance of AI happened in computer vision. People attribute the start of AI to different points in time. Some say that AI started in 1956-57 with Dartmouth Conference, a very well-known event in the history of AI. Some say that AI started in 98 when Jan LeCun introduced LeNet for handwritten OCR. I, among many others, think that another renaissance of AI, it was in 2012 when Alex Kryzhevsky and the company introduced a new concept of deep neural networks, and AlexNet was actually the start of that renaissance. The ImageNet computer vision competition, I like to call that the Olympic Games of computer vision and AI. Within 3-4 years, human level accuracy was beaten by convolutional neural networks. And to me, as the guy who joined a computer vision startup and actually developed OpenCV along many other public contributors, it's very dear to my heart that I was actually in the domain. I was very close to the domain, and I was actually helping the industry with a renaissance in computer vision. And after computer vision, with the introduction of transformers by Googlers, 2017, deep learning went further. The translation tasks and more or less like text-related tasks, we all have been the witnesses of Gen AI and LLM. I'm going to call it revolution. It's been over a year. I think GPT was made available November 30th, 2022. The whole world has changed since then. The whole world revolves around Gen AI and LLM. And so when I browse through my LinkedIn, every other person is an expert in Gen AI and LLM. But that's my story, and I guess simple and complex at the same time.
Wow, exciting. LLMs and Gen AI is making AI visible to the whole world. It's not like they're inventing it, but they're making it much more abundantly available. Interestingly, you and I have that in common. I also worked on cancer. You came from computed tomography, and I've been of the beneficiaries because I just took a CT scan, and it's so useful to see your heart and different parts of your body from different angles. It's such an amazing technology. So thank you for that. I worked on expert systems for reducing the toxicity of cancer medicine. It's so fulfilling to work in that industry. What was your work like? Those are the early days of tomography, right? When you got into it?
It was a special type of tomography. It was optical coherence tomography. You heard of femtosecond lasers, right? Very short pulses. The shorter the pulse, the better the spatial resolution of your technique. Femtosecond lasers are large. If you want to make those laser pulses very short, the whole machine is like a very large room, and it needs to be cooled. Everything needs to be controlled for pressure and for everything. About 30 years ago, there was a very interesting invention. People invented the so-called superluminescent diodes. Those diodes could actually send continuous light, but with very short coherence length. It's a very simple thing. It's literally a few $100s, unlike like femtosecond laser. Those superluminescent diodes shoot light near infrared region with very short coherence time. You can use those sources to actually image in depth of your tissue. So optical coherence tomography, which we worked on, we created so-called optical biopsy. Doctors, whenever they like inspect your stomach or like esophagus, they send the endoscope in, shine light, and they look for suspicious areas. And whenever they see something which doesn't look normal, they take a biopsy. Then a few days later, they process the biopsy and they know if it's inflammation or if there is something suspicious. But optical biopsy, you see something suspicious, you put the probe on the place. If it's bad or good. If it's good, you don't need to take biopsy. If it's bad, you take biopsy. What kind of bad is in the spot? That's what we worked on. We made endoscopic optical biopsy, and it was like miniature optical coherence tomography. Optical coherence tomography is used right now in ophthalmology. Whenever they need to visualize retina in the eye, that's what's used. The optical coherence tomography, it's very, very fine resolution. It's not a computer tomography, which is a whole bunch of X-rays bundled together. It's actually totally different type of light source and very different wavelength and very different part of human body. They look at mucosas and oral cavity, stomach, esophagus, colon, and on, like cervix in women, for instance.
Yeah, I'm familiar with that one too. Used for detecting macular degeneration early.
So in ophthalmology, yes, that's OCT. That's the very same principle, just a bigger machine, but very fundamental underlying principle.
Technology initially used in military and other areas, radars and all, is now used in understanding and supporting life, reducing all the problems that we get, whether it's from ultrasound days to OCT and many other forms of tomography. It's amazing technology. So you said something very interesting, that real AI as we know it today really started with deep neural networks. And you were involved in OpenCV. How OpenCV and the standards in computer vision changed and made it possible for us to get into much more intelligent networks.
Computer vision is where the concept of deep neural nets was first applied. The first 2-3 years of ImageNet competition, it was shallow networks, and they would give you above a 30% error. ImageNet is over 14 million images and classified into about 1,000 categories. So essentially, you are talking about differentiating cats and dogs, the recognition part of that. There is a detection task, like do object detection. There is a task of doing semantic segmentation, like pixel-wise recognition. Like 2010 and 2011, they were shallow networks and very high error rate. So algorithms simply did not deliver. In 2012, AlexNet showed a huge drop in error from like 25 and 30 to 16%. That was huge. It was a deep multi-layer architecture of the neural network. Starting from AlexNet, in the next year, improvement went below 10. The idea of deep neural networks picked up. Research around that area just exploded. It was exponential, and it's still kind of on the exponential curve. 2012 was first DeepNet. By 2015, convolutional neural networks beat the human level of accuracy. Human level was roughly 3.5–4%. Even humans sometimes mistake dogs for cats and cats for dogs. Some of those ImageNet images are tricky. If it's a curled up cat, you can mistake it with a dog and vice versa. So that was unprecedented. About 2018, the term AI started presenting itself. Before that, it was deep learning. Some people would call it machine learning, and deep learning indeed is a part of machine learning. And machine learning has been successfully applied to solve many tasks, for instance, in machine vision in factories since 70s, 80s. Deep learning as a technology, like the concept of using many layers, took other domains by storm. NLP, natural language processing. Translation tasks finally got solved when transformers were introduced in 2017. Recurring neural networks kind of popped up, but they didn't stick around. People applied them for a temporal analysis and like activity recognition. They tried applying them like LSTMs for translation as well, but it was not until transformer concept and transformer architecture was introduced by the Googlers, the problem was solved. So like kind of deep learning marched across various domains. Going back to computer vision, there was pretty substantial amount of hype in the beginning. What I find very interesting is how similar things are in different domains. In computer vision, things started kind of small. Then those networks grew out of proportion within a year and a half. They grew huge. VGG16, VG19, those networks were humongous. Considering those times, slowly but steadily, sanity kicked in. You cannot have a cluster to serve every camera in the world if you want to do analysis of computer vision data coming in. It needs to be a few cameras hooked into a little box, or many cameras hooked into the server, not the other way around, right? Like many servers hooked to a little camera. Researchers started looking into informational density of those networks, meaning like how much accuracy you get per parameter. They started looking for lighter topologies compute-wise and smaller memory-wise, because again, you need to be economical if you want to deploy. Nobody can afford to have a $100,000 cluster. It just doesn't work that way. Within 5-6 years, things became sane and robust. The sizes of those networks became a serious consideration, the memory footprints and everything. We see the very same processes happening in Gen AI. In the beginning, they were moderately sized and like GPT-1, 2, and 3. Then they grew out of proportion. Now everybody is talking about 7 billion parameter networks like Llama 2 and Qwen and ChatGLMs of the world. 2 quarters ago, everybody talked about 180 billion parameter Falcon, which was actually developed in Abu Dhabi by Technology Innovation Institute. People who I know very well and respect. They first introduced a moderately sized 40 billion parameter, then they did 180 billion, huge network. I think they're down to 7B or 6B with a Falcon. Sanity kicked in within probably 2-3 quarters, which was faster than the computer vision. Right now, the talk of the day is ability to run those LLMs and Gen AI like Stable Diffusion kind of networks on a laptop.
So it looks like this idea of doing all AI on one large cloud at the heart of the system is shifting, looks like, towards the edge. How can edge AI, whether it's inferencing or even federated learning, change the way we do things today?
Again, I'm going to be talking about computer vision, and I'm going to be like kind of drawing parallels. In the beginning, when there was not enough compute at the edge, the concept was let's send all the videos to the cloud and do the processing there. So there are multiple considerations which actually prohibit that. Number one is bandwidth. It's not economical to send all the videos up to the cloud. There is not enough backhaul, and there won't be enough backhaul because the number of cameras is growing very fast. There are more cameras than there are humans in the world right now. That number keeps on growing. So that's one consideration. Another consideration is security and privacy. GDPR in Europe does not allow you to send certain stuff to the cloud and store it without consent. So those considerations like backhaul and privacy and security, it's best to act upon data locally and only send up findings to the cloud for analysis, for storage. There are certain things which require cloud. For instance, if you want to run a really large network and you don't want to install a cluster at the edge, then you are going to have to send your data to the cloud for processing simply because you cannot run that at the edge. From the top of my head, more than 50% of data, especially like video data, is acted upon locally. So there's enough of understanding of how to run video analysis, and there's enough of compute at the edge to take care of what you need to take care of at the edge. In the Gen AI and LLM field and and it's going to be an interesting game. There is a mix of proprietary LLMs and open LLMs. Apparently, folks like OpenAI are not keen to allow their stuff to go to the edge because they lose control over it. So therefore, they would demand the users and developers to use the cloud API and to run the inference in the cloud. But there are very interesting open source alternatives like Mistral by Mistral AI out of France. Meta bought 20 billion worth of hundreds. I've been amazed at how much open source goodness Meta has released to the world. That's exemplary.
I like what you talk about, especially when you're talking to young people. How can we have a very practical, pragmatic approach to having responsible, ethical AI?
My rule of thumb is when there is too much hype, there's very little reality. When you hear Gen AI and LLM from every iron and from every media outlet, they do it for clicks, they do it for hype, maybe cheap fame. It actually does a huge disservice. If I were to look at 1 year of Gen AI and LLM madness, I'm going to call it madness because if you look at market caps of those startups, OpenAI is like 80 billion
80
plus.
billion.
80 billion plus, 700 people. Nokia and Ericsson, two companies which serve 50% of the world's population. When it comes to radio access networks, core networks, our mobiles are on Ericsson and Nokia. They combine are about 32 billion. Just imagine how much IP is in those companies, and they made mobile communication possible. All of those people, and we are talking about tens of thousands of people working across like all 5 continents, working on 5G, probably on 6G, and what have you. A startup with 700 people is like 3x the market cap of 2 companies combined. That hype is excessive and it's not market justified. When all hype is done and gone, things are going to have to be economical. In computer vision, if you build a camera which does traffic license plate recognition for your cars. If your cameras don't deliver desired accuracy and they cost too much, you would be out of the market very swiftly. The CV market is already in the economical zone. Now, Gen AI and LLM generate very little revenue. There are no revenue benchmarks yet, but they talk a big game about changes which are going to change the world and everything. So like they are definitely in the hype zone, but it will pass maybe within a year and a half, 2 years. Things will have to get economical. Investors are not going to be able to keep on putting cash in those startups if those startups do not start making money. Many will die. Those who are the strongest and the smartest will stay, but things will get economical. So those initial market valuations will drop. I've seen many reports about like unicorns costing like 10 cents on a dollar, 5 cents on a dollar when hype is gone. And hype will be gone. There will be another hype in quantum computing, but Gen AI and LLM will stay. How and where and how much, your guess is as good as mine. But we as users will have to vote with our money, what we need, what we don't, what we find robust, what we don't find robust. Going back to practical AI, there is work. I work for Intel after Intel bought our company, but I also do certain things which move me. I like to talk to students. Once a month, I go to a university. I'm pretty well connected to local universities. I offer them like a lecture, a workshop for a few hours, and I always like to do an open floor kind of questions when you have them. I've been talking about practical AI for the past year or so. I try to talk sense into students, see through hype, wait for things to get economical, and they will get economical, like whether we want it or not. I mean, it's gravity. We cannot ignore gravity. Even if we choose to ignore gravity, we are still going to be pulled toward Earth. Like laws of economics is gravity. So no matter how much hype there is now, it'll go, and that thing which has been flying with hype will have to land. And gravity will pull it towards the Earth. I've been telling them, like, be practical, how you place your bets, don't follow the hype blindly. So it helps with market valuations, it helps with raising money for startups, but it actually causes more damage, in my opinion. What we see right now in Gen AI, too much hype caused too much attention, and we are already seeing attempts to regulate. I read Biden's executive order pretty solidly. They don't differentiate between development and deployment. While I wholeheartedly agree that deployment of AI needs to be regulated, development should not be regulated, because we are talking about a license to develop AI. You saw a New York Times lawsuit against OpenAI alleging that OpenAI used the copyrighted data without their consent. Too much hype brings too much attention. I do have a little bit of worry that we might actually face another AI winter because of that.
It reminds me of the dot-com days and Napster
Yeah,
putting all videos on the web. And now YouTube
indeed.
has actually brought that balance back. The creators get credit and get
Yeah,
visibility without
yeah.
the fear of losing everything. And I think something similar has to happen to bring that balance back. Thank you for reminding us that there is always these bubbles. I have a friend who calls it micro bubbles. We've been through the bubbles in crypto, we've been through the bubbles in blockchain, and now I think sooner or later we will have to face the bubble in Gen AI and LLMs, which reminds me, in order to make the edge and even companies successful, organizations successful, I think there's a lot more need for connectivity. And you worked in connectivity earlier. Do you think private 5G is a feasible solution? As you correctly pointed out, today we can't even live without Ericsson and Nokia to be able to get things done. How far will connectivity have to go to make it possible for AI to become practical and be available in a meaningful way?
I was invited to the event, and they are talking about 6G. They are talking about even more spectrum, and they're talking about even better utilization of spectrum, essentially how much information you pass per hertz. At some point, we are gonna exhaust our capability to pack more data. That's why they're going after more spectrum. And private 5G, there are deployments. Allegedly, private 5G is better than Wi-Fi. If you have a factory and you need to deploy a private communication solution, private 5G is the way to go. What's interesting about 6G is they are talking about turning those 6G networks into sensing networks. They want to offer some extra capabilities than just pure communication, more value-added services. It has not been standardized yet. Very early discussions, but that part is interesting because like you have many antennas out there, you have many sensors out there. I wonder if we are actually getting everything we can get from that huge network of sensors. They are correlated. That information is time stamped in those networks. They synchronize against the sensor clock. It is interesting. So far, it's been more or less a bit pipe users, and like operators and telecom equipment manufacturers have been like dying to differentiate. I want them to succeed, and us, humanity, to leverage that and get as much as possible out of what's out there.
Essentially, what you're saying is that 6G will bring together not just the networking aspect, but also the IoT, the sensing, and the ability to actually do things at the edge.
That's what I understood, and that's what initial discussions are about, the ability to sense the world through those sensors and through those networks. You have a car going towards your radio. If the retro reflection is frequency shifted, which way car is going. Therefore, you can extract a lot more information about the world around you. So not just pass bits and bytes between servers and devices. You can sense what's happening, and you can do that in the paradigm of existing gear already installed. It's very pervasive given how many radio base stations are already installed out there. It's going to be very interesting to see if operators and telecom equipment manufacturers are going to be able to turn that into something meaningful. It's going to happen within the next few years, so we are going to witness that.
You moved from engineering into biz dev and executive roles. When I listen to you, you're totally into engineering. What was the transition like to go from pure R&D roles into business roles?
I spent 10 years doing science and 20 years doing business. And I had a 3-year overlap. 2003 through 2006 is when I ran 3 companies and when I still wrote code at night. I was still working on papers and stuff like that. And I stopped writing code in 2006, 18 years ago. I had a 3-year kind of cooling off period, going from science to the dark side of business. It was tough, and I'm an Epicurean in a good way. Satisfaction you get from exploring and finding interesting stuff, probably stronger from making more money, at least for me. I loved those years. It was pure. You work day and night, 12-hour, 14-hour days, and you have elder colleagues looking over you. And again, I was a kid. when I was allowed to join an actual lab. Elder colleagues, already PhDs, some already have doctorate, they would spend time with me. They would babysit me, they would guide me, and they would help me. It felt great. They allowed me the honor of discovering things. Even when they guided me like probably 90% of the way, they would still allow me to feel that joy, like I discovered everything myself. It was amazing. Nothing compares to that.
So now you have traveled to 45 countries. You've worked in various environments, in engineering roles, business roles. Where did you find the most interesting roles, and how did you grow through all this travel, working with so many different people?
If I were to look back at 20 years of my life, my best years were the years with the startup Itseez in computer vision. I loved every day of that. I miss those times. We got 4 kids. Our youngest actually saw me every day. Our first 2 kids did not see me. And the third kid kind of saw me. Those years I was on a plane every other week, titanium with Marriott, highest grade with Lufthansa, and a couple other airlines. I lived on a plane. We needed to develop business. We needed to grow. We needed to know the world about us. I would be at CES, at the Mobile Congress, at the Embedded Vision Alliance get-togethers in the spring and in the fall. I would be everywhere. I would be living on the road. Lots of action, meeting great new people, old friends. When you grow business like 3x in a couple of years, what was interesting is we got our term sheet from Intel on my 40th birthday, exactly on the day. It was a nice gift, one of the most interesting and precious days in my life, a similar level of accomplishment. The only thing I regret, it was too fast. It literally took us 2 years and a few months, November 2013, and we got the term sheet in March 2016. We grew very fast and we got snatched very fast as well. Probably I wanted that to be a little longer.
That's amazing. Congratulations. That's a precious gift indeed. And now I don't see any slowdown in you, Alex. You're always available when I write to you, mornings, evenings. What is it that you are most excited about at this stage in your career? Where do you see the most interesting technologies, opportunities to serve?
I told you about OpenCV, fully open source, Apache 2.0 license, commercially available and totally available to humanity. Upon joining Intel, the team which we brought, that team was very capable technically. That team brought quite strong culture of accomplishing stuff. That team developed a product called OpenVINO, also open source product. Apache 2.0 license that allows developers to deploy across a multitude of hardware easily. Essentially, if you are a data scientist and you train a network, you need to deploy it. Things are pretty complex because deployment requires you to know the hardware platform, it requires you to know how to pipeline, and it requires you to know quite a few additional things which are not expected of a data scientist who can train a network. OpenVINO bridges those two worlds, the world of training deep learning networks and deploying them on various hardware. I am very proud of the team which developed the product. I kind of feel that we delivered again. Even after the acquisition, the team still delivered something awesome with many downloads, many developers using them, and the thousands of companies deploying products using OpenVINO at the edge, in the cloud, on the client. So I feel actually great satisfaction personally as a guy who actually brought that asset to Intel, and that asset actually delivered. We did that, very proud for the team.
I found out about it at the Intel Innovation Conference in 2022. It's amazing, the concept of how you create a shared vision, not just for a company, but for the good of the whole community. There's still a lot of anxiety, partly because of the hype, partly because of the misguidance. But students, young people, people in mid-career are worried about their careers. They're worried about where to go, what to do. What advice do you give to these people?
There was a generative AI assembly here in UAE in the fall, October 23. We had a guest. So UAE is the first country to have an AI minister. His Excellency Amar Al-Alama. He actually cracked a joke. He asked the audience the difference between complete and finished. His response was funny. If you embrace AI, you would be complete. If you do not embrace AI, you would be finished. In a way, AI is not a threat. People who embrace AI would be better off going forward. That's a technology which is here to stay. That technology is not going to replace, it's going to augment us, help us. Those who oppose it and those who do not use it for productivity and for routine tasks would find it harder than the others in the world, I think. And there will be some professions which will be replaced, especially those with no creativity component to it. It's not going to lay bricks for us per se and grow wheat. The AI will help us lay bricks through robotics and through like agricultural robots, like killing weeds and stuff like that. So it will help us, but it will not replace us. I would not go into purely mechanical jobs right now with no creativity component to that. Again, people keep on talking about AGI, like artificial general intelligence. I don't think it's going to happen anytime soon. It's one of those things where hype does us quite a lot of disservice. Not going to happen in the next 40, 50 years, maybe even longer. But definitely AI is going to do more and more things at the same level as us. Creativity is hard to beat. Mechanical tasks, simple tasks are very easy to be done with it. To stay ahead of the curve, the young kids need to embrace AI and use it in their daily life and for work and focus on high value add tasks, which AI cannot deliver yet. That's what I tell my kids as well.
In our generation, it embrace calculators and not just do multiplication tables all our life. Today, we are much better off because we don't study multiplication tables as much. We do estimation and let TurboTax for doing taxes. But there are many more things. We travel more. We are doing many more interesting things today. So this is why I talk to you people. You bring in so much richness to my life. I learn every time I talk to someone who has lived in and seen different aspects of what's going on.
Life is interesting. My hope is that we are not going to have AI winter. Once hype dies out, things become a lot more productive. You can focus on doing actually meaningful stuff rather than chasing way too many things at once. There are many other things that play. Quantum computing is interesting as well, and neuromorphic computing. There are other things happening in research which are hugely interesting. They will start materializing soon as well.
Very true. Now, when we look at the dot-coms, we don't even call them dot-coms. Internet is totally here to stay. To people out there, I want to know what you are facing. What are the challenges? What do you think about the hype? What do you think about the reality of AI? And about many more technologies. What fascinates you? Alex, it's a joy talking to you. And I've seen OpenVINO literally do magic. I talked to Ria recently, and she's been doing magic with it, with many startups, with many companies. And none of them is going to take away all our jobs, but will help us reduce the mundane, help us do things that are even more interesting and meaningful. So thank you for shedding light. I hope you continue to support young people so that they get over all the craziness of the times and find sanity and find meaningful ways of going forward in their life and in their careers.
That's my commitment to the world. Thank you so much for having me, Shankar.